Hello everyone, I welcome you all to today's session of question discussion again. So today I bring a question from time and distance for us all to discuss, right? So the level of difficulty of the questions that we pick up in these sessions, right, series of sessions, is all mixed, right? So just like your CAT examination, so the question that we'll be discussing here varies from sometimes easy, alright, mostly moderate, sometimes difficult level questions also, right, just as we have in our CAT examination. So before we start the discussion, what I would suggest is you can just pause the video at this moment. So this is a question from time and distance, as I was saying, alright. Pause the screen, try out the question yourself once, right, for some time, and then you can resume the video for listening to the discussion that we'll be having here. However, here I'll be straight away starting with the discussion. Let's get started with the question. It says, Abhi and Sam, let's call them as A and S, start from a point on a circular track of length 180 meters at 12 am. Run in opposite directions. They meet for the first time at the starting point. So again at the starting point at 12:20 am. The ratio of the speeds of Abhi and Sam is 3:5. Find the time taken by them to meet for the very first time. So it is given to us that they meet for the first time at the starting point at this. So what is the time for them to meet for the first time? Please understand firstly, these two meetings are two different meetings. So here the specification is the meeting first time should happen at the starting point. Whereas here the meeting is happening for the very first time, not necessarily at the starting point. Right, so there is a difference. Please notice the difference out here. Right? Now let's just try to represent the situation here. So situation can be represented using a circular track like this. So length of the circular track is given to be 180 meters. Right, I'll write that. Then we have couple of people, Abhi and Sam. Let's call them as A and S, who are running in opposite directions. So let's assume Abhi is running anti-clock and Sam is running clockwise. The ratio of the speeds is also given 3:5. So let's assume speed of Abhi is 3s, then speed of Sam will be 5s. Okay. Also they started running from this moment, from this point at 12 am. So they are starting at 12 am. Okay. They are again coming back to the same point at 12:20, that is after 20 minutes. So can I say the time taken for them to meet for the first time at starting point is 20 minutes. And please note, we have a formula for finding out the time when two people will be meeting at the starting point. So just to recap that, so if you have a track like this, length of the track is L, there are two people, there could be more than two also. Let us say speed of A is A meters per second, speed of B is B meters per second. So the time for their first meeting at the starting point is given as LCM of time taken by A to complete one circle, L by A, length of the track by speed of A, time taken by B to complete one circle, L by B. So this is how you can find out the time for the first meeting at the starting point. So that is given to be as 20 here. So length of the track is also given. So let's consider the speed. So can I say time taken by A to complete one round will be length of the track by speed of A. So this turns out to be what? 60 by S seconds, right? Let's say this is 3s meters per second, the speed units. Now time taken by B to cover one round will be length of the track by speed of B, which is going to be 36 by S seconds. Now once we know this too, can we not say that LCM of these two, 36 by S, is going to be 20 minutes. Let's also write that in seconds. We can say this. So what is LCM of these two? Let's calculate it separately. 60 by S, 36 by S. I want the LCM. So we have a concept in numbers. LCM of fraction is nothing but LCM of the numerators upon HCF of denominator. Now by the way, denominator is same. So HCF is going to be same number as. So what is LCM of these two? So it's going to be 180. 60 and 36 when you calculate the LCM. Don't go for the regular way of calculating every time, right? So don't go like 60 prime factorization is what, 36 prime factorization is what, then you go for LCM calculation. That might take longer time sometimes. Since 60 and 36, if you look at it, there is a big common factor that we have, 12 5s, this is 12 3s. So thus my LCM will be 12, definitely will be there. Now besides 12, there will be a 3 also, there will be a 5 also. So thus 12 into 3 into 5 is a direct way of getting to the LCM instead of the conventional approach that is taught in the classes, right? Or the conventional approach you would have learned. So LCM is 180 by S seconds. So thus can we say 180 upon S should be equal to 20 into 60. So when I calculate this, right, observe what will happen now. 60 will go 3 times. So S is going to be 3 upon 20. Okay, S is 3 upon 20, and hence we can calculate the speeds. What will be speed of A and speed of S can be calculated respectively. That's not the question, so let's not bother about that for the time being. Now what is the question? Time taken by them to meet for the first time. Now please understand, once you know the speeds of A and S, which can be calculated now, as I said. Now the first time they'll be meeting, they'll be traveling like this. Listen to this carefully. The time in which Abhi will cover 3 parts of the distance, Sam in the same time will cover 5 parts of the distance. Yes or no? Because ratio of the speeds is 3:5. Now from the moment they start, that is 12 AM, to the moment they meet, they'll be traveling for same amount of time. That means time is constant. So whenever time is constant, in such cases we can say ratio of speeds will be equal to ratio of distances of the 2 individuals. So thus we can say ratio of the distances should be 3:5. So that means A will cover 3 parts and S will cover the remaining 5 parts. Now what does 3 parts mean? Let's continue on the next slide. So thus can I say distance traveled by A is 3 parts, 3:5 is the ratio, out of 3 plus 5, 8 parts into 180. So this is the distance traveled by A. But we have to find the time. So thus can I say time for the first meeting anywhere on the circular track, not necessarily on the starting point. Can I say this time will be nothing but time taken by A to travel 3/8 of 180? Because when A will travel like this, S will travel like this, and they will meet here for the first time, right, along the circular track, right? They'll be meeting for the very first time, right? So thus the time taken for the first meeting will be distance that A travels upon speed of A. Now what is speed of A? 3S. So 3 into 3 by 20. So when you simplify, 3 will cancel out once. 3 can be cancelled out one more time, 16. So this will become 20 will come in numerator by 8. So when you simplify, 4 goes 2 times, 4 goes 5 times. This will go 30 times, giving us the answer of 150 seconds. So this is how we can try to answer the question, and that was the question exactly. Find the time taken in seconds. We are anyways answering in seconds by them to meet for the first time. So thus can I say the answer should be 150 seconds. Are we clear with this? An alternate way of looking at this question can be, I'll just clean this entirely. Let me just clean the portion that I don't want. Another way of looking at the problem. Let's try to understand that as well. So consider this circular track. Consider this circular track. Now we have a property in circular tracks in time, speed and distance topic, which is if ratio of 2 people is A to B, right, ratio of the speeds of 2 people is A to B, and they are running in opposite directions, then the number of distinct meeting points is A plus B. And similarly, if they are running in same directions, the number of distinct meeting points will be A minus B or B minus A, depending on which one is bigger. So here they are running in opposite directions, right? So thus can I say number of distinct meeting points will be 3 plus 5, the sum of the ratios, which is 8. So what would 8 distinct meeting points mean? Observe. So this will be, let's try to divide the entire circular track into 8 equal portions, right? So I'll try to do it this way. 2, 3, 4. 5, 6, 7 and 8, like this. Now please notice how will they be moving? Notice the time in which A will cover 3 parts anti-clockwise, B will cover 5 parts, right? So that means after traveling for every 3 units of distance, unit is this part, right? They will be meeting, right? So A will travel 3 units, so 1, 2, 3. This is where they will meet for the first time. Then again 1, 2, 3. This is where they will meet for the second time. Keep listening. 1, 2, 3. This is where they will meet for the third time. 1, 2, 3. Fourth time. 1, 2, 3. Fifth time. 1, 2, 3. Sixth time. 1, 2, 3. Seventh time. And lastly, this will be the 8th time. This will be the 8th time. Now please notice the 8th meeting is again happening at the starting point for the first time. And that is given to be as what? So for 8 meetings, the time taken is 20 minutes. We want it in seconds, right? So I'll write it 20 into seconds, 60. So for one meeting, the time gap for one meeting will be how much? So can I say it will be straight away 20 into 60 upon 8, which will again be giving us the answer as, when I simplify, 150 seconds. We could also do it like this. There is no need of assuming the speeds as 3 years, 5 years, taking LCM, etc. Nothing is required if we understand it this way. So once again my answer turns out to be 150 seconds. I hope we are clear with this second approach also, because in a competitive exam scenario, you are expected to think on your feet, right, then and there, right? So if you go by the conventional approach, you might not be able to solve most of the questions, right? You won't be having sufficient time. So sometimes you'll have to do some kind of intelligent guesswork, right? Some other times you'll have to go for some substitution approach. Some other times you'll have to go for checking out, eliminating the option choices, approximating sometimes the calculations. You have to learn so many things, right, if you want to do well in these MBA entrance tests. I hope we are clear with this question. So with that, we have come to the end of the session today. Thank you. All the very best.